Assalamualaikum warahmatullahi wabarakatuh. My name is Mubarak bin Muhammad Bakri, and today I'm going to present about experiment 6, Bourdon tube pressure gauge. First of all, abstract. The aim of the experiment is to perform pressure calibration on a Bourdon tube pressure gauge using a dead weight tester. This experiment is carried out by placing a piston into the cylinder and rotating or pushing the piston to expel the air bubbles inside. The pressure gauge deflects as the piston is put into the cylinder for initial reading. Then, one by one, load weights are added till the total mass reach 6 kg. For a total of 2 times, the procedure for increasing and lowering the weights are repeated. The experiment is conducted successfully, and as true pressure, which is standard known input, is almost the same as the pressure recorded the output. The input reading is the outweight on the piston, produce unknown pressure in the vessel equal to the weight divided by the piston area, while for the output reading can be obtained from the pressure gauge. Next is objective. We have 3 objectives for the experiment, which is to calibrate a Bourdon tube pressure gauge using dead weight. Second, to establish the calibration curve of Bourdon gauge, and to compare the experimental result with theoretical values. Okay, next is introduction. One of the most important process for ensuring instrument accuracy is instrument calibration. It is the process of configuring an instrument to provide result within an acceptable range. A dead weight calibrator was used to impart known weight to a fluid in order to test the accuracy of pressure gauge reading. To measure the pressure intensity at any point in a static or flowing fluid, the various types of pressure measuring instruments have been used. The Bourdon tube pressure gauge is one of these devices. Because of their reliability, compactness, low cost, and ease of use, Bourdon tube pressure gauges are the most commonly used today. It consists of curved tube of elliptical cross-section bent into a circular arc.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So the theory for this experiment is, the Bourdon gauge is the most popular pressure measuring device for both liquids and gases. It can be connected to any source of pressure, such as pipe or vessel containing a pressurized fluid. So the Bourdon gauge is fitted with a transparent dial, which lets you see the internal workings of the gauge. The gauge consists of a thin wall, closed-ended tube which is oval in cross-section. This tube is bent through an angle of about 270 degrees along its long axis. The upper end of the tube is welded to a hollow mounting block, which allows the pressurized fluid to reach the tube. So you can see in the figure 1 the Bourdon gauge. As it becomes rounder, the Bourdon tube tends to uncle, which causes its free end to move. Okay, next, in order to obtain very accurate pressure measurements, it is important to regularly recalibrate the gauge. This is because the tube tends to become weaker with extended use. So the usual pressure is to apply a known pressure to the gauge using a device called a dead weight calibrator. The normal calibration procedure is to load the gauge for known pressures using a dead weight calibrator, including a liquid of non-specific gravity, which is used water as the liquid. This dead weight tester uses a simple piston and cylinder arrangement to provide a source of pressurized liquid, which is transmitted to the gauge. Okay, for the equation for this experiment is P is equal to F over A, as is same with M times 2G over A times to 10 to the power of -3 kilopascal, where F is force applied to the liquid in the calibrated cylinder. A is cross-sectional area of the piston. M is total mass including the mass of the piston. And the last one is G, which is acceleration due to gravity. Okay, we move to apparatus. So the apparatus for this experiment is piston, Bourdon tube pressure gauge, and dead weight. Okay, the next is methodology for this experiment. So number one, a cylinder and a connecting transparent tube were filled with oil. Second, piston was inserted to cylinder. Third, ensure the bubble were removed. Next, the first reading was recorded. Weights were loaded slowly. The second reading was recorded. Number 7, steps 5 to 6 were repeated until total weight reached 6 kg. Number 8, unloaded the weight by remove one weight. Number 9, write down the reading for removing each weight. Number 10, steps 8 to 9 were repeated until the weight removed from piston. And the last one is step 2 to 10 were repeated until 2 times to get average reading. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan bin Mokhtar, and I'm going to present about the result and the discussion. For the results are given completely in the table with the mass added, the total mass, the actual pressure, the pressure by total mass, the gauge pressure for loading and unloading, and it is for 3 experiments and its average values, and finally the percentage error. For discussion part 1, we are asked to calculate the percentage of relative error for the theoretical and measured experimental pressure gauge. And in our calculation, we have that the mass of the piston is 1 kg, and the cross-sectional area of piston in the video is 3.1731 times 10 to the power of -4 meters squared. As you know, the formula for pressure is pressure equals to force over the area. So we find the force over the area for the pressure exerted by the piston, and we get that the force is the gravitational force, the mg, and where g is 9.81 meter per second squared, and we find that the pressure exerted by the piston is 30.9 kilonewton per meter squared. While for the pressure exerted by the total mass, we pick for the first mass that is added and the total mass. We get that the pressure exerted is 46.4 kilonewton per meter squared. And for the average calibrated pressure and the percentage of relative error for loading, we calculated the average pressure, which is 30.3 kilonewton per meter squared, and we calculated the percentage of relative error, where it is the measured value minus the actual value over the actual value times 100%, and we substitute in the numbers, and we get that the percentage of relative error for loading is 34.7%. And we do the same thing for unloading, where the average pressure is 40 kilonewton per meter squared, and the percentage of relative error is 13%. For discussion part 2, the source of error and the method to minimize the error. The first source of errors is that the dead weight pressure gauge, it responds slowly to the change in pressure, and in order to minimize the error, we can rotate the piston so that we can remove the air bubbles, and from that we can reduce the frictions as well. And the second source of errors is that there might be air bubbles from the cylinder and the hose, and we can minimize the error by removing the air bubbles from the cylinder and the hose. And for the third source of errors, it might be from the the equipment's sensitivity towards vibration. And to minimize such error, we have to handle the load and the unloading of weights really carefully. And for the last source of errors is the parallax error, and in order to minimize the error, we make sure that the eye is perpendicular to the reading, and we make sure that we read the measurement properly. For discussion part 3, the repeatability and the accuracy of this equipment. For the repeatability is a measure of how consistent the pressure gauge can repeat the same measurement when all conditions remain the same. For example, if we expose the same pressure on 2 separate occasions, the gauge would show the same PSI, the same pressure, if all other factors such as pressure, temperature, etc. remain the same. For the accuracy is quite similar to repeatability, and it's important in determining the quality of the Bourdon tube pressure gauge. And accuracy is a measure of how effectively a pressure gauge is in repeating the upscale reading on the downscale cycle if all conditions remain the same. For the conclusion, we can conclude that the Bourdon tube pressure is a suitable equipment to measure pressure, and even though the readings were not that accurate as the actual values, the readings which were recorded are consistent and actually close to the actual value, and the errors, it cannot be corrected, but it can be avoided to a minimum. That's it. Thank you.